Okay. These questions are from, gosh, what chapter is that? 13? Yeah, I think it's 13. This is concentration unit. So I'm not sure if I'm going to be able to get through all of these. It's just kind of a lot of questions. You might want to work one or two on your own, but let's do a couple of them at least. So 10.5% by mass. So this one is converting from one concentration unit to another. Convert from mass percent to molarity and mass percent to molality. So that's one type of question. This one is just calculating mass from a mass percent. And this one is calculating a volume that contains a certain amount from a parts per billion. Okay, so since these two are kind of similar, let's go ahead and just do this one and this one, so you can kind of see the two different types. So I'm going to start here because I think this is a little bit easier and it'll help introduce the one above. Okay, so what mass of sucrose is contained in 355 mils? So this is our volume of a soft drink that is 11.5% sucrose by mass, and it also gives us the density. So let's define what this concentration unit means. 11.5% means 11.5 grams of sucrose per 100 grams of solution. And remember, solution is solute, or in this case, sucrose, plus the solvent. Okay, so again, we're not going to do that one, and I'm just going to have to continue this work down here. Okay, so if there's 100 grams of the solution, it already told us that there's 11.5 grams of sucrose, okay? So let's kind of write that in more detail. 11.5 grams of sucrose and, oh, you know what? I don't even think we have to go to that level of detail for this question. So let me just finish it because I think it's useful for later. So we could actually write the total down here as well, 11.5 grams sucrose, and then the difference between 100 is going to give us 88.5 grams of the solvent. Okay, but since this is asking us in volume, we actually don't need to go into that detail, okay? We're just going to start with our volume, the 355 milliliters, and we're going to use the density to convert that to grams, because then we can use this as like a conversion factor to get us from grams of the solution to grams of the sucrose. So this is milliliters of the solution. Okay, we're going to use the density. So let me map this out for us. We're going from volume of the solution to grams of the solution to grams of the solute. This here we're going to use density to do this conversion, and this here we're going to use the mass percent. Okay, so for the first step, remember, I do density calculations as a conversion factor. So I'm going to put milliliters on the bottom and grams on top. You can do it like an equation if you want. Density equals mass over volume. They're the same thing. So the density is 1.04 grams per mil. Okay, so I'm going to multiply 355 times 1.4. And that's 369.2 grams of solution. So they actually wanted to know the grams of solute, the sucrose. So like I said, I'm going to use the mass percent written out in this form to convert that. So I'm going to take that 369.2 grams of solution. I need to have grams of solution on the bottom to cancel out and grams of solute on the top, because remember the solute is the sucrose here. That's what I'm trying to get. So this one was 100 and this was 11.5. Okay, so 369 times 11.5 divided by 100. Oops, messed that up in my calculator. 1 second. 11.5 divided by 100. Okay, so that is 42.5 grams of sucrose. So what we just answered was the grams of sucrose in 355 milliliters of the solution. Okay, the other one is a conversion between mass units. So we're gonna start off similar. Let's go ahead and define what this concentration means. 10.5% is 10.5 grams of glucose over 100 grams of solution. Now, instead of just using that, let's go ahead and see how we can convert that to a new concentration unit. So I'm actually going to do the molality first, because that one's a little bit easier. Well, I'll write both of them out, but then we'll do the molality. So to go to molality, we need moles glucose over kilograms of the solvent. Okay, this is going to be a little bit more complicated because it's the solvent, not the solution. Okay, for the molarity, we're going to start off the same way. And we're going to convert that to moles of glucose per liter of solution. So this one actually is easier. Maybe we should start there. So what we're actually going to do is we're going to solve the top, and then we're going to solve the bottom, and then we're going to divide one by the other. So we're going to convert the 10.5 grams of glucose to moles of glucose. And we're going to convert the 100 grams of solution to liters of solution using the density. And then we're going to divide top by bottom, and that'll give us the molarity. Okay, so in the first one, we're using molar mass. In the second one, we're using density. Okay, so it is really loud. There's a neighbor kid over here, and all the way upstairs, they're playing Legos, and it is going all the way down to the next floor. Okay, 10.5 grams of glucose. We're going to need the molar mass of glucose. So let's go back over and look at that formula. C6H12O6. I think that should be about 180, but let's go ahead and check. 12.01 times 6 plus 1.008 times 12 plus 16 times 6. Yep, it's 180.156. So the moles here, it's actually nice because we get to use this in the next calculation too. 10.5 divided by 180.156. So this is 0.0583 moles. So that's our numerator in both of these problems now, both in the molarity and in the molality. Okay. Oh, yeah, molality is the one down here, but it's going to be the numerator in both of those. Okay. So then the second thing is we need to convert grams of the solution to liters of solution using the density of 1.03. So 100 grams of the solution times 1.03 grams per 1 milliliter. That's going to give us the volume in milliliters. I'm going to go ahead and add the conversion to liters in there as well, because that's the volume we're looking for, is liters, not milliliters. So 100 grams divided by 1.03 divided by 1,000. So that is a volume of 0.0971 liters. What's the definition of molarity? Moles per liter. So we're going to divide moles by liters to get the molarity. 0.0583 divided by 0.0971, or 0.60 molar. So a solution that is 10.5 mass percent with this particular density is 0.60 molar. Different way of expressing the concentration. Okay, now for the molality, it's a little bit harder because we have to use that thing we talked about earlier, that the 100 grams of solution is that 10.5 grams of solute plus whatever's going to make it a total of 189.5 grams of solvent. That's where the 100 grams of solution comes from. Why is that important? Because we're going to take that 89.5 grams and convert it to kilograms to get the denominator. So the top was moles of glucose, 0.0583 moles of the solute over the kilograms solvent. So all I have to do here is take the grams and convert it to kilograms. Okay, or 0.00895 kilograms. Okay, so the molality oh, you know what? I think I added an extra 0 in there. I did. Yep. 1, 2, 3. Okay. Let's fix that up here as well. 0.089. All right. 0.0583 divided by 0.089, or 0.66 molal. Okay, similar, not identical.